Hello and welcome to Maths with Mr Amison. In this video we're going to start to practice how to use circle theorems. Now, I'm going to focus on two circle theorems in this video, and that's going to be the angle at the centre is twice the angle at the circumference, and the angles in a semicircle are 90 degrees, because they are pretty much the same thing. If you need to recap this topic, then please watch Mr Chowdhury's video. So I'm going to start by sharing two examples. I'm going to show you the example, then I'm going to talk through it, and then I'd like you to copy it down and have a go at the examples on the right. Feel free to pause anytime. So in these examples, for this first question, we know that the angle at the circumference is half the angle at the centre, or the angle at the centre is twice the angle at the circumference. Now, that's only true if both of these angles come from the same points on our circle. So this point here and this point here, both of radii both come from those points, but also the angle at the circumference also comes from those points. Therefore, the angle here at the centre is going to be double the angle here at the circumference. So this angle is going to be 104 degrees. Here, a common misunderstanding is to think that because this angle is at the centre, that this angle will be half of this one, because they both come from the same points on the circle. This one goes to the centre and this one goes to the circumference. However, the angle here is inside the quadrilateral that is formed. So this one is not double this one. You can see in this first example, this angle was inside our quadrilateral that's made. This angle was outside of the quadrilateral that's made. So if we want to find this angle, we need to find the angle at the centre that's outside of the quadrilateral that's made. So this angle here. And we know that around the point at the centre of the circle is 360 degrees. So if we take 52 away from 360, it gives us the angle outside of our quadrilateral being 308 degrees. Then the angle at the circumference is going to be half of that. Therefore, x is going to be 154 degrees. Copy that down. Make any notes on it that you need to. Once you're done, have a go at the questions on the right. Now you've had a chance to copy down and have a go. Let's go through these questions. So you can see the angle here is at the circumference. This is at the centre. Both angles come from the same points on the circumference. And this angle is outside of our quadrilateral. So the angle at the centre is double the angle at the circumference. So our x is half of 52, which is 26 degrees. Here you can see that our angle that we're trying to find is inside of our quadrilateral. So what we can do is find the angle outside of our quadrilateral first, being double 104, to get 208 degrees. And then the x plus 208 would make 360 because of angles around a point. So if we take 208 away, we get our value for x being 152 degrees. Alright? So here are 6 questions for you to try. See if you can find the value of x in each question. Question 1, 2, 3 and 4 are fairly standard. Question 5 is a bit trickier, and question 6 is a difficult looking question, but it uses the same principles. Have a go. Alright, so for question 1, you can see that x is double 73 because that's at the centre outside of our quadrilateral, and 73 is at the circumference coming from the same points. So x is 146. Similarly, for question 2, we have the same setup except the 73 and the x have swapped places. So the x is half of 73, so 36.5 degrees. Question 3, you can see that the 73 degrees here is inside our quadrilateral, so the angle here is going to be 360 minus 73. So our x is going to be half of that, so half of 360 minus 73, which ends up being 143.5. Question 4, you can see, to find the value of x here, you can see this is a straight line, okay? Because that's a straight line, then the angle at the centre is 180 degrees. Or in other words, when we have a diameter, the angle here is going to be half of that 180. Therefore, this is going to be 90 degrees. So whenever we have a circle that's split in half by a diameter, or in other words, whenever we have a semicircle, the angle at the circumference is always going to be 90 degrees. Which means for question 5, because this is 90 degrees, then this angle has to be 180 degrees. So 2x plus 34 is 180, or double the 90 here. And we can solve that equation by taking 34 away, then divide it by 2 to get our value of x to be 73 degrees. Question 6 is tricky. Alright. Question 6, we have to recognise that this is our angle at the circumference, and we don't make a quadrilateral this time. You don't have to make a quadrilateral for angles at the centre and angles at the circumference. This time we make a kind of bow tie shape where one of the points of the bow tie is at the centre of the circle. That's key, because not all circle theorems questions are going to have a bow tie shape with one of the points at the centre. Alright, but in this case we do. So this angle x and the angle at the centre, the opposite side of y, this one here is going to be double the value of x here, because this is our angle at the centre coming from this point and this point, and this is our angle at the circumference coming from the same 2 points. Okay, so you can see that the angle at the centre is going to be 2x right here. But because that forms the other side of this angle y, that means the 2x plus y is going to equal 360. And then I can rearrange that to make x the subject. I can take y away from both sides to get 2x is equal to 360 minus y. And then I can divide by 2 to get x is 180 minus a half of y. Alright. Well, thanks for watching. I hope you found it useful to go through some questions to do with circle theorems, to do with angles at the centre, and speak to you soon.